We are live. Got 3 people watching right now. Oh, there it goes. All right, I'm gonna wait a couple more, like a minute or so. Uh, this particular stream might take a few more minutes to get through, just because there was a lot of questions. There's uh, 28 questions. Not sure I can get through that in 15 minutes. So if you get tired of watching, just you can it'll the video will come up and you can watch it later. That means the next lesson will be going up a little bit later than normal or than scheduled. Uh, but there's a lunch break, so you'll have plenty of time to get that next lesson done. Uh, this quiz, you can see we had uh, an ampacity of a 1 gauge THW copper conductor installed in a raceway located in an ambient temperature of 55 degrees Celsius. So, this question is going to direct you to uh, this table in your code book. This table is 31015B16. And let me zoom in on that just a touch. That might make it a little bit easier. Well, I will zoom in all the way. If you look at the top, so this is table 31015B16. It's allowable and passive conductors with not more than 3 current carrying conductors in a raceway, cable, or directly buried, based on an ambient temperature of 30 degrees Celsius. So that's what this table is about. It's conductors in a raceway based on a certain temperature. Going back to the question, it's in a raceway and the temperature is different. So let's get our first number off of here. It's a 1 gauge THW. If you look here, you've got columns. This is copper. I don't know if y'all can really see my pointer. This is a copper conductor right here. This is a it's copper conductors. That's a THW. All of your wet location wires are 75 degrees Celsius. All of your non-wet location wires and -2 is 90 degrees Celsius. And then 60 degrees Celsius is for Romex and Romex-like conductors. And this is the insulation rating, not the ambient temperature. All of this is based on 30 degrees Celsius ambient temperature. So you come down here and you have 130 amps. All these numbers here are amps. Number 1 copper, number 1 copper, THW. You come down and it's 130 amps is the starting amperage. But like I said, this is a different ambient temperature. It's a lot hotter, which if it's hotter in the ambient temperature, it's going to lower your rating, lower your amperage rating. So you're going to flip back 2 pages to table 31015B2A, and I'm going to zoom in on this. Oh yeah, that's much better. 31015B2A, and it has, you're going to take the temperature rating of your conductor, which was 75 degrees Celsius, and you're going to come down. They gave us the temperature in Celsius, and it was 55 degrees Celsius. And you're going to come over and you will have 60.67 is your multiplier. So you'll come to your calculator and do 130, which was our original uh, amperage, and multiply that by 0.67. Once you hit enter, that's going to give you 87 degrees, or 87 amps is your amperage allowable. Now, I think only one person got to that 87. So good on them. Somebody left their book in their truck. Nobody put 130, so that's weird. Ah, okay. So, a handful of you put 110, and that would be if it was a underground feeder or I don't know what type of insulation TW is, but this column is for Romex. That first column is all for Romex. All right. And then in my notes on this question, I put that temperatures in the code book are generally stated in Celsius in the metric system. The metric system is the standard measurement system in the code book. Just so y'all have that piece of information. A conductor's allowable ampacity is directly related to the type of insulation. We covered that just then. This whole chart is the columns are the types of insulation. So this is asking you to read the title of this chart. Table 31015B16 is not more than 3 current carrying conductors. So there is that. Temperature correction table, which is that 31015B2A that I had showed y'all a second ago. So as it gets hotter, the ampacity of the conductor decreases. So this is going to be false. The opposite is true. There is a explanation there. I'm going through these a little bit faster because we kind of covered all this. Wanted to try to keep this as close to 15 minutes as possible. Okay, so this question is about the next page over, which is 31015B17, which is about open air conductors, or like the service drops coming in from the pole. That's going to be open air conductors where there's plenty of airflow around the conductor, so there's not a conduit holding the temperature up against the conductors. Single insulated 2-gauge THW conductors installed in a raceway at an ambient temperature of 30 degrees Celsius have less ampacity than when installed. Okay, and this is taking the same conductor and comparing it between the two tables. What you'll do with this is you'll take those two tables and just compare the same conductor on the two tables. And of course, open air is going to have more capacity than in a conduit, because the conduit holds the temperature in. It insulates the conductor's temperature more. Okay, this is directing you to a new table. 31015B18, that is for a different type of conductor, or a different type of insulation. Let me flip a couple pages. So B18 is almost identical to B16, except the types of insulation is different. And there, it's drastically, it's like a very high temperature insulation. So that will, you just read that table like any of the other tables. So that one is just looking at that column on, basically all this one's saying is UF and TW are in the same column. That's all they want. Temperature rating of THWN. Again, you can look at this column. THWN is right here. It is a 75 degree Celsius wire. Also, there is a very large chart. It is 310.104A is that chart or table. The 310.104A is a table that covers all the different insulation types and gives you a detailed explanation. I will put that in Discord. For you guys. And I'll also put it in the chat. I don't know. I don't think that the video records the chat, but there it is if it does. And same question, just a different type. Rule of thumb, if it has a -2, that is a 90 degree Celsius wire. And if you look at 310.104A, you can see a little bit more detail. The standard temperature rating of THWN-2 is 90 degrees Celsius. If you use it in a wet location, it drops down to 75. But the correct answer here is 90. Excuse me. Branch circuit is defined in the NEC as... This is Article 100. Just straight up go to Article 100 and read the title of the definition of branch circuit. Again, Article 100, definition. This one is going to be still in Article 100, but you're going to have to read a couple different definitions and see which one of these answers is the correct definition. Let me zoom in just a touch. See if that makes it a little bit easier. I know some of you guys are on the phone and you might not be able to see the smaller text. Because of a long circuit length, the branch circuit supplying parking lot lights is installed using 10 gauge THW copper conductors. The conductors terminate on a 20 amp circuit breaker. The rating of this branch circuit is 20 amps. Generally, you are limited by your weakest link. The rating of the circuit would be 20 amps because the smallest thing on that circuit is 20 amps. You upsized it to 10 amps for voltage drop, not for amperage issues. Wire branch circuit shall be provided with a means which will simultaneously disconnect all ungrounded. So, what this is saying is that if you do a multi-wire branch circuit, so sharing a neutral between multiple circuits or other things like that, you need to put them on a breaker that one action will turn off everything that's connected together. The branch circuit voltage for luminaires in a dwelling unit is limited to blank nominal between conductors. So I should cover. Did that previous one have a? Yeah. So 210. Article 210 is about branch circuits. So you should flip to Article 210 for answering questions about branch circuits. And this one, question number 15, is about multi-wire branch circuits. So you will want to look up multi-wire branch circuits in Article 210. You can use the index to get yourself a little bit closer. I believe 210.104 is not 210.104, 210.4. 210.4 is multi-wire branch circuits. So that would be a dead giveaway for where you should be looking. Branch circuit voltage for luminaires in a dwelling unit is limited to blank. So that's going to be looking for branch circuit voltage limitations. That's what this question is about. And you're going to look that up and find it. It is 120 volts. And that's a simple enough thing to remember, is that lights inside of a dwelling unit are 120 volts. They do not want 240 volt lighting circuits. End users have to interact with them too much for it to be like changing light bulbs and stuff. It's not just electricians interacting with them, so they don't want regular people to be working with that. Which of the following commercial locations generally do not require GFCI protection for? So, inside of Article 210, there is a ground fault. It's 210.8, ground fault circuit interrupter protection for personnel. And if you look through there, it's commercial, so that would be other than dwelling units. And it has a list of places in there that do not require GFCI protection. That is 210.8B is where that is. There is a lot of overlap between 210.8A and 210.8B. Just so y'all know that. And then 210.8A is... Now, if you look on both of these questions, it's finished portions of basements and finished basements. Basements are a place that would normally need to be GFCI protected, but if it's finished in, it's just like another room of the house and does not need GFCI protection. unless there's a water source nearby, or it also classifies as a laundry room or one of the other places that needs GFCI protection. Uh, Number 19, ground conductor. So the neutral of a branch circuit is most commonly identified. So this is Article 200 talking about the grounded conductor. It is generally white or gray. It is one of the few, like, the ungrounded conductor has almost no rules about what color it needs to be, but the grounded conductor has a lot of rules, and if you flip to Article 200, you will see 200.6 has the means of identifying grounded conductors. Again, that's 200.6. Receptacles rated 15 amps are permitted to be installed on both 15 and 20 amp branch circuits. This is true. That is because the faceplate of a 15 amp receptacle is different from the faceplate of a 20 amp receptacle, and things that are required to be plugged into 20 amp receptacles have a different plug. One of the prongs is straight up and down, and then the other prong is sideways. And 15 amps, they're both straight up and down. That makes it where you couldn't plug a 20 amp device into a 15 amp receptacle. So that's why you can put 15 amp receptacles on a 20 amp circuit. So, was the maximum load permitted to be in cord and plug connected into a 20 amp branch circuit? That's going to be back in the branch circuit section. And so if you look at 210.23A1, it covers cord and plug connected equipment not fastened in place. But that's not exactly what we're looking for. Generally, cord and plug equipment shouldn't be. Here it is. Here's a better spot for it. 210.21B2. And it's basically the maximum load. It's 16 amps. It's basically 80% is what they're going for there. The maximum rating of a 30 amp branch circuit with more on outlet is 24 amps. And it's exactly the same spot. It's table 210.21B2. Okay, I put the wrong spot. It's also there. Not really. 24 amps is 80% of 30. Yeah. So it's just stating it differently, but it is clearly stated in 210.21B2, if you're following along in your book. A multi-wire branch circuit for an individual piece of utilization equipment supplies a line to neutral load. So 210.4C. So this is multi-wire branch circuit, so that's 210.4. like we had covered earlier. Flip too many pages. C is line to neutral loads. Multi-wire branch circuits shall only supply line to neutral loads, meaning that they cannot supply line to line loads. You cannot have a multi-wire branch circuit that some of the loads are 220 and some of the loads are 110. So you couldn't supply an oven and a light or something. An oven and a blender. In dwelling units, the voltage between conductors, the supply luminaires. So we covered this already. That was very early in the quiz. Voltage between conductors or luminaire, so light fixtures in a dwelling unit cannot have more than 120 volts. That is voltage limitations. 210.6 branch circuit voltage limitations. And inside of there is luminaires. Building is required to be located on the same level and within blank. Within line of sight, 25 foot. That's shorter than line of sight. So you need to have a receptacle where they can reach it with a decent length extension cord. They don't need that extreme of extension cord. That's 210.63. This should be required receptacles. So that's heating, air conditioning, and refrigeration equipment. And that's just showing that you have to have a receptacle available for the people working on it. The courtesy plug is what they call it. Hallways and dwelling units. This is going to be actually required receptacles. If you flip back a page from the last question, dwelling unit receptacle outlets, spacing, wall space, floor receptacles. There is, I believe, a section for... So part 3 is required outlets. And there should be a section specifically covering hallways. Yes, it's in H. Oh, that's convenient that they put H as hallways. It doesn't normally work out like that. So 210.525, or let's see, C. No, that's not C. It's H. 5H, or 210.52H is hallways. And it tells you how long the hallway needs to be. And that is 210.52H. I could have just shown the explanation. I'd have had it. Receptacles mounted in or on floors located within 18 inches of a bedroom wall in a dwelling unit are permitted to be counted as the receptacle outlets. Yes. You are allowed to count it as one of your required receptacles if it's within 18 inch of a wall. If it is not within 18 inches of a wall, it's just a bonus receptacle, and it doesn't count as part of the requirements for how far apart your receptacles can be. So, inside of required outlets, electrical service equipment is one of the sections. 210.64 is electrical service areas, and that is 25 feet. It's the same as the AC unit rule. Hey, that's the last question. Only took me 30 minutes to get through 28 questions. That's not bad time. All right. I'm going to stop the stream here. If nobody has any questions, feel free to ask me questions in the Discord. Remember to like and subscribe to my YouTube channel. I think all of you subscribed already, though. I have like 16 subscribers now. All right. I will get back with y'all in a couple hours after lunch.